Imagine a vast cosmic symphony composed of an immeasurable number of stars, planets, and moons, all moving in perfect harmony as if following a timeless score written into the very fabric of space. Yet, within this grand orchestra, one particular section has puzzled and fascinated astronomers for centuries: exoplanets. These are natural worlds that orbit stars far beyond our own Sun, hidden deep within the spiral arms of the Milky Way galaxy. Some are gas giants larger than Jupiter, others are barren, rocky wastelands, and a few, just a precious few, bear a striking resemblance to our own Earth. Among these distant cosmic neighbors lies one world so intriguing, so eerily familiar, that it could be considered our planet's mirror image, our cosmic twin. Through the sharp, unblinking gaze of the James Webb Space Telescope, we set our sights on this remarkable candidate, Proxima B, located a mere 4.2 light-years away, practically next door in galactic terms. The James Webb Space Telescope is revolutionizing how we see the universe, pulling back the curtain on worlds that, until recently, existed only in theory. Imagine, for a moment, drifting through the Milky Way, a colossal galaxy containing an estimated 1 trillion exoplanets. If each one were the size of a grain of sand, they would not only fill the Grand Canyon from rim to rim but also create a second Grand Canyon just as massive, stretching for miles. This thought alone is enough to challenge the limits of imagination. Even more staggering is the fact that astronomers believe 20% of these worlds may be Earth-like, possessing atmospheres and geological conditions that could potentially sustain life. That's a 1 in 5 chance of discovering a true double of our world. And for each such planet, there could be moons, rocky satellites locked in eternal gravitational dances, that might also harbor the right conditions for life to emerge. This is where the James Webb Space Telescope becomes indispensable. Its primary mirror spans 6.5 meters across, 2.7 times larger than Hubble's, allowing it to collect far more light from distant objects. This incredible sensitivity enables Webb to detect the faintest glimmers from stars billions of light-years away, while also revealing the fine details of planets orbiting them. Equipped with powerful infrared detectors and advanced spectrometers, Webb functions like a forensic laboratory in space. It doesn't just look at planets, it studies their atmospheres, searching for the chemical fingerprints of life: water vapor, methane, carbon molecules, and oxygen. This is astronomy taken to the next level, the science of detecting life without ever leaving home. Among all the exoplanets known to us, Proxima B stands out as one of the most captivating. Discovered in 2016, it lies within the habitable zone of its parent star, meaning temperatures could allow liquid water to exist on its surface. If oceans truly exist there, they might be as deep, as vast, and as mysterious as the Mariana Trench here on Earth. But Proxima B is no perfect Earth clone. A single day on this alien world lasts the equivalent of 11 days on Earth, creating long, drawn-out sunrises and sunsets that would bathe the planet in endless golden light. Beautiful as that may sound, it raises important questions. How would such extended day-night cycles affect climate? Could human biology adapt to this rhythm, or would ours? Then came a discovery that deepened the mystery and set the scientific world buzzing with excitement. While focusing its gaze on Proxima B, the James Webb Space Telescope detected a signal unlike anything seen before. It wasn't just random static or the faint whisper of cosmic background noise. It was structured, patterned, and strangely deliberate, almost as if someone, somewhere, had intended it to be heard. To the trained ears of astronomers, this was no ordinary blip on a data chart. It carried a complexity, a rhythm, that nature rarely produces on its own. Almost immediately, scientists began whispering the word that ignites both hope and controversy: technosignature. A potential trace of technology, the calling card of an advanced civilization. For a brief and electrifying moment, the entire idea of life beyond Earth shifted from speculation to possibility. Could this be it? The long-awaited proof that somewhere, across the great cosmic ocean, another intelligent mind exists? Around the world, telescopes reoriented, researchers scrambled, and the public held its breath. And then, silence. The signal vanished as abruptly as it appeared. No follow-up, no echo, no repeat transmission. Only an empty channel and a flood of unanswered questions. Was it a fleeting burst from some unknown natural phenomenon? Was it the result of a rare cosmic alignment, never to happen again? Or, and this is the question that lingers like an echo in the dark, was it a deliberate message, carefully timed and targeted, meant to brush past us like a cosmic whisper? The debate has not ended. If anything, it has only intensified. Some scientists argue for caution, warning against jumping to extraordinary conclusions without extraordinary evidence. Others see in this fleeting anomaly a hint, a fragment of a much larger cosmic narrative that we have only just begun to uncover. Determined not to let the mystery fade into the archives, Harvard researchers have taken the search a step further. They are transforming the James Webb Space Telescope into a kind of cosmic night vision device, capable of detecting faint artificial light on the shadowed sides of distant planets. The goal is as bold as it is thrilling: to find the glow of alien cities shining in the darkness. Imagine it, a skyline of distant towers, their lights spilling into the night, visible across light years. A civilization's quiet announcement to the stars: we are here. No radio waves, no greetings in human language. Just light, steady and unwavering, cutting through the void. The James Webb Space Telescope is far more than a stargazer's tool. It is our most powerful key to unlocking the deepest, oldest questions of all. Are we truly alone in the universe? Is life a rare spark, igniting only under the most perfect conditions? Or is it a common flame, burning quietly on countless worlds we have yet to see? Could there be civilizations older, wiser, and far more advanced than our own, civilizations that have already mastered the mysteries of existence, while we are only beginning to ask the right questions? The answers to these questions could reshape not just science, but the story of humanity itself. They could change how we see our planet, our history, and our future. But this search is not a sprint toward an easy revelation. It is a marathon of exploration, one that will span decades, perhaps centuries. Each new discovery is a step forward, a piece of a puzzle so vast we cannot yet see its edges. And yet, every step matters. Each observation draws us closer to the moment when we might finally understand the truth about our place in the universe. Perhaps, one day, we will look back and realize that we were never alone at all. That the universe has always been alive with voices. We simply lacked the ears to hear them. Because the cosmos is not silent. It is a living, evolving, restless expanse, and with the James Webb Space Telescope, we are finally learning how to listen.